Bismillah ar-Rahman ar-Rahim. I am Ayman Ibrahim, a member of the SRI group. Today we're going to discuss a very interesting topic that's going to be the risks and odds. I know this might be scary at first, but we're going to make it easy. Today's plan will be divided into two videos. There is this video in which we'll discuss the risk, the relative risk, attributable risk, and a little bit on the number needed to treat. And then there is another video that I really recommend you go watch after this, in which we'll discuss the odds ratio, and the difference between the relative risk and the odds ratio. So first of all, let's start with the risk. We'll ask ourselves, what is risk? Risk, put in simple terms, is the probability of an individual getting an outcome. Yeah, for our purposes, this is mostly would be the probability of a healthy person getting a disease. But keep in mind, the word risk is neutral, so it doesn't have to be the disease. It can be any kind of outcome, but usually it is the disease that we're talking about. So it's actually pretty easy to calculate. If we have the number of cases of the disease, and we divide them by the number of people at risk. And if you remember the previous video, we said that the people at risk are those people who can get the disease, but they are not actually having it right now. So basically, we're just dividing the number of ill people on the number of health of all people, you could say, of all people. Risk alone can be very misleading though. Try this sentence with me. If somebody just came and told you that people who wear glasses have a 50% lifetime risk of developing cancer, well, you might actually freak out, especially if you are wearing glasses. But if I told you that also people who don't wear glasses have a 50% lifetime risk of developing cancer, that means that glasses has nothing to do with it, right? Whether you wear glasses or not doesn't matter. So in order to really understand how would glasses affect the probability of cancer, we would need to compare these two. We need to compare the chance of having, cancer while wearing glasses to having cancer, in general. And this is this is an article if you want to learn more about the lifetime risk of cancer in Korea. So one kind of study where we frequently measure the risk and compare the risk is the prospective cohort. I know you already know the prospective cohort, but we're just gonna review it anyway. So remember, we have a population at risk in which we are interested, and therefore we divide them into two groups, and into that is exposed and non-exposed. And then in each of these groups we measure who gets the disease and who doesn't get the disease. And you remember that we were interested in comparing these two, the exposed and the non-exposed, to see who develops more disease or less disease than the other. And therefore we can understand the relationship between this exposure or risk factor to the outcome or disease. Okay? So a good and easy way to compare the two groups is to calculate the risk first. If you can calculate the risk in the exposed group and calculate the risk in the non-exposed group, we can compare these two risks and then understand, what is the relationship, or understand perhaps how did the exposure affect the risk of these people. Did it increase or did it decrease their risk of having the illness? So the cool name we give to this kind of calculation is the relative risk. In the relative risk, we just basically compare the risk in the exposed to the risk in the non-exposed. Look at this. The relative risk equals risk of disease in the exposed divided by risk of disease in the unexposed or the non-exposed. Pretty simple, right? And you can imagine the number will go something like this. Either it will equal 0, if the relative risk equals 0, that means that the numerator and the denominator are equal. That means that the risk in the exposed and the non-exposed are the same. So the exposure does not make any difference. So if you ever find that the relative risk is 1, that means there is no difference between the two groups, the ones who are exposed and the non-exposed. In this case, people who are wearing glasses or not wearing glasses. Okay? However, if the relative risk is more than 1, that means that the numerator is bigger. That means that the people who are exposed have a higher risk of the disease. So this means that the disease exposure is dangerous. It increases the risk. The opposite is also true. If you have a risk that is less than 1, that means the denominator is actually bigger than the numerator, and therefore that the exposure is actually protective. That means that the risk of disease in the people who are exposed to this whatever is actually making them safer and less likely to have the disease. One also very interesting term you will come across is the attributable risk, and it's actually pretty simple. Attributable risk is basically how much of the overall risk is this risk factor responsible for. You see, we have an overall risk, like, each one of us has an overall risk of cancer. But if, for example, somebody was smoking, how much does smoking contribute to his risk of cancer? We can calculate this through the attributable risk. And it also has a pretty simple equation. Attributable risk equals the risk in the exposed minus the risk in the non-exposed. I think a visual representation will make this easier. Look at these two groups here. The orange represents the risk or the diseased population, and the gray is the overall population. Okay, so here if we divide the number of diseased on the number of the whole population, we'll get 50%. Okay, so here in the exposed, 50% of those people exposed will develop the illness, and 30% of those unexposed will develop the illness. Okay, so that means there is this little difference here. You see this little difference here that has changed because of the exposure. The exposure has increased the risk by this amount. So here, if we actually subtract the orange area from this overall area here, we will get the attributable risk that we can attribute, or we can say it is caused by the exposure. Okay, so let's do a little exercise to practice what we've learned. So here we have the cases, which are the diseased people, the non-cases, which are the healthy people. We have the exposed people who are exposed people, and the non-exposed people who are not exposed. Okay? So if we want to calculate the risk in the exposed population, what would we do? You remember that the risk is the number of cases divided by the number of the population, right? So in this case, we will divide 90 by 100, and therefore we get the risk that is 0.9 or 90%. So the risk of having the disease in the exposed population is 90%. What if we want to calculate now the risk of the disease in the unexposed population? So now it's also very easy. We're just going to calculate the same. The cases divided by the total. So we're going to get the 300 divided by 1000, which will be 0.3 or 30%. So now we easily calculated what is the risk in the exposed and what is the risk in the unexposed. Do you remember what we can do with these two values? We can measure the relative risk. So the relative risk, as you remember, is the risk in the exposed divided by the risk in the unexposed. So in this situation will be 0.9 divided by 0.3, which will be overall 3. So the relative risk of this exposure, whatever it is 3. That means people who are exposed are 3 times more likely to have the illness than those who are not exposed. Another thing we can calculate is the attributable risk. And the attributable risk, as you remember, is the subtraction the risk in the exposed minus the risk in the unexposed. So here 0.9 minus 0.3, which is 0.6. So 0.6 of the risk can be attributed to the exposure, whoever people in this study were having. Simple, isn't it? Also, here's one quick tip. You can easily calculate the number needed to treat by the reciprocal of being or it is actually the reciprocal of the attributable risk. That means if you just flip or calculate the maqloob of the attributable risk, you can easily come up with the number needed to treat. That's all for this video. I hope this actually made things a little more clearer for you. And don't forget to see the other video about the odds, because it will complete the concept in your mind.